This video will help to explain how containment surveillance measures are implemented at a facility. The facility we're considering here is a light water reactor. At this reactor, the spent fuel pond is separate or outside of the reactor containment building. This means there must be two complementary containment surveillance measures, one applied over the storage pool and one applied on reactor containment. You can see here that the storage pool has two video cameras. One surveillance unit is monitoring the pool and the area itself, while another surveillance area is monitoring the exit hatch. Inside of reactor containment, you can see that there's only one video surveillance unit monitoring the area. There's a secondary unit applied monitoring the equipment door. You can see here that if an additional hatch exists at the facility, an additional video surveillance unit can be put in place to monitor the hatch for access. With video surveillance units, there are two types of points monitored at a facility. The first being the area where the nuclear material will be stored or in place, and second, at any access points to the facility. You can see at this facility there are two exterior hatches, and each of these is monitored by a video surveillance unit. An additional containment and surveillance mechanism utilized at this facility is the seal, or the TID. You can see in the spent fuel pond there is a canal that connects the pond to the reactor pool. This canal is there to allow the operator to remove fuel from the reactor core and place it in the spent fuel pond. The IAEA will typically place a seal on the canal gate. This allows the IAEA to know whether or not fuel has been removed from the reactor core and moved to the spent fuel pond. An additional point where seals are used is on the reactor cover, or the reactor dome. By placing a seal here, the IAEA can monitor if the reactor core was opened at any point, and then using video surveillance they would be able to determine if fuel was removed from the reactor core or not. At this facility, you can see that the IAEA would typically place seals on the equipment door that leads to the exterior of the containment building. By placing seals on this door, the IAEA will know whether or not access to this door has been allowed. If the seal is found to be broken, the IAEA can use this to then go back to video surveillance and determine what activities took place after the seal was broken. There are two containment surveillance measures that are missing from this facility that you see here. As you can see at this facility, there is an overhead crane that is used to remove fuel from the reactor core and then to move the fuel around the reactor facility. At some facilities, the IAEA may place a seal on one of the access mechanisms to this crane. By placing a seal on the crane, the IAEA will know if the crane was used to move fuel around the facility. If the seal is broken, when the IAEA inspector comes to the facility, this signals the IAEA inspector to review the video surveillance data to determine what activities occurred after the seal was broken. An additional containment and surveillance mechanism that could be utilized at this facility are radiation detectors. These radiation detectors might be placed along the transfer canal between the reactor pool and the spent fuel pond. By placing these detectors in the transfer canal, the IAEA can monitor the detectors to determine if any fuel has been moved through the canal. These radiation detectors could also be connected to a piece of video surveillance equipment. Whenever the detector registers radiation, which would typically mean that a piece of fuel is moving through the canal, this would trigger the video surveillance to capture an image or capture a series of images until the registered radiation has ceased.